Good evening, ladies and gentlemen. Thank you for giving me a stream. I will today talk about documentation sour cabbage. And sour cabbage is kind of cabbage preserved by lactic acid, and in China, coming from China, and is known as kimchi. It's also known in Korea and this case. And during Mongolian raids, it came to Europe. This showed that dark fermentation is preserved food and can be used as dark fermentation because dark fermentation is a specific kind of anaerobic digestion that stops oxygenesis and hydrogen production, and optimal pH is about 5 to 6. The sour cabbage pH is from 3 to 4. Thus, is very proper, seems to be suitable for dark fermentation because it shifts to lower pH and even not producing methane. If so, the dark fermentation can be a reason to form an static conditions. And dark fermentation, in case of sour cabbage, in case of untreated inoculum, gives very little hydrogen, jump in the first time, and then transferring to methane, because was very fast preparing and going from lung. And in case of pretreated pH, a pretreated inoculum, so prepared by heat shock by boiling in 105 degrees for 30 minutes, then it came to longer production and more stable and quite high in event 390 milliliters per gram of sour cabbage. The sour cabbage contains some little part of beside lactose-only proteins, so we could measure if dark fermentation is reliable for hydrogen sulfide from feed or from organisms. In sour cabbage containing protein and sulfur contained was lower than produced emission. So produced emission need for coming from organism. The hydrogen sulfide, therefore, is parallel to the hydrogen production. And therefore, we can observe this dependence, and I prove them. And this shows that dark fermentation is very proper and good option to utilize our cabbage. Thank you very much for listening.